At differentiating exponentials. Now this comes from your OneNote lesson 15 differentiating exponentials from Sadler Unit 3 exercise 6b. We can start off by looking at a simulation I've made on Desmos, and it sort of shows something pretty amazing, and then we're going to show it using first principles. So we want to differentiate an exponential function. So here we go. So first thing we might want to consider is a function that looks like this, 2 to the x, right? So this is an exponential 2 to the power of x, and we can see, 2 to the power of, 1 there is going to be 2, and 2 to the power of 2 is 4. So we can see this exponentially increasing. When it's to the negatives, it's going to be half, quarter, etc. Now, let's have a look at the gradient function. So I've just turned that on. So we can see that the gradient of this function at any one point is slightly lower than it, okay? Now, let's turn that off and go 3 to the x. Now if we look at 3 to the x, we can see that we've just plotted the gradient function, and that's that like dashed line there, that the gradient function lies above it. Now, if we plot h here and we go on k to the x, we can have a look and see what happens when we look at the gradient of this line and see if we can find some kind of pattern. So we know that if we plotted 2 and then plotted 3, the 2 to the x, the gradient function was underneath, 3 to the x, the gradient function was above. What happens if I plot 2 point something 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 to the power of x? What can we get to happen? Can we get that gradient function to match up? Now as we bend it up, you may notice something pretty amazing. You can see we've gone over there. What number do you see popping out here? Do you remember your exponential number? So we can see here, 2.71, that the gradient of this curve is also the same as the function itself, okay? And this is that special number e, the exponential function, okay? So, I don't know what's happening there. It seems to be loading up, so we're gonna go back to that. I've never seen that in my life before. Loading, I've never seen that. Cool. Now that exponential function is basically where the gradient meets up, and we're going to show that using first principles. Okay. Now it says installing. I don't know what that means. Okay, this is very unusual. Lovely, here we go. So we've just had a look at that. Now what we want to prove is that the differentiation of the exponential function is the exponential function. So here we go. First step here, we go and remember our differentiation by first principles. First thing, f of x is equal to e to the x, and therefore f of x plus h is equal to e to the x plus h. Next we're going to take our limit. So hopefully you remember this. Okay, next step we sub in what we know. So f of x is going to be e to the x plus h, take e to the x on h. I'm just leaving a blank side here, that's our limit, okay? And then we go e to the x times by e to the h, take e to the x on h. Next, let's factorize out that e to the x on the top. Okay, now we're getting somewhere. So e to the x, e to the h, take 1. We're going to now write it like this. E to the x times by h to the 0, e to the h, take 1 on h. Now, we can explore what happens when h approaches 0 for this function, e to the h, take 1 on h. Now over here we can see that table of values. Now remember, what's h approaching? 0. So when h is at 1, we can see it's 0.1, it goes to 1.05, and then as we move down, and plugging in less and less numbers, we can see that this tends to 1, the value 1. So this is the limit that this approaches. So it becomes e to the x times by 1, or simply e to the x. What have you just shown? If we have this function, e to the x, then if we find the gradient function, it's also equal to e to the x. It's absolutely amazing. So the gradient function of e to the x is itself. Okay, it's absolutely an amazing function. differentiate to itself. Thanks for watching this video. Hope you found it useful. In the next video, we're going to be differentiating using this principle.